Good morning, everyone. Today, we will explore the LaPadula model, a foundation framework for computer security. This model gives us a formal handle confidentiality in systems with multiple security levels. So, let's dive in. Computer security has always faced two big challenges. First of all, software eventually has bugs. Remember the mythical man month? Second, the building systems that resist attacks is incredibly hard. Take Windows NT in the 90s. It is promised high security but failed, becoming full of vulnerabilities. This is why we need better approaches. So, why formal models? We need mathematical proof that a design meets security goals. Also, we must ensure that the actual system designs the US Department of Defense funded early research here. Even today, these models gives us discipline and clarity in defining security requirements. So first one is logical or mathematical proof, and the second one is design, implementation, and fidelity, and the third one is historical context. This is the historical context which initial research is funded by US Department of Finance. So next is the introduction to the actual Bell LaPadula model. The first one is origins. It is developed in the 1970s as a formal model for access control. Foundation is based on access control concepts where each subject and object is assigned a security class. File object gets a security class in strict hierarchy. So what's the main goal here? Stop the unauthorized information leaks. It is the most influential model for multi-level security systems focused only on confidentiality, access control, and security levels. So the next one is the basic concepts, security and class levels. Security hierarchy. Security classes from strict hierarchy is called security levels. And security clearance assigned to subject to responses and mean users or processes. And the security classification assigned to objects, files, data. Categories or compartments can be added to each security level for more granular control. So here is the core idea. Security classes from hierarchy. User gets clearance like top secret, files get classifications like confidential. We can also add categories like finer controls and all that. The military uses levels like top secret, then the confidential, then the restricted, then the unclassified, then the simple, right? Then we go for security level in different context. We know that we do have different contexts. This isn't just for the military. Companies use similar hierarchies. So first we think strategic, which is corporate plans, and then the sensitive financial data. Then comes the confidential internal opportunities and operational data. Then comes the public shareable info. The same structure but different labels. This provides models flexibility. So LaPadula's model is not only for military, it is also applicable in all the companies with similar hierarchies. Next one is access models in the BLP model. Access modes. First one is read. The subject is only has a read access to the object. Information flows from object to subject. Next is the append. Subject only allow write access to the object. Information flows from subject to object. And then comes write. Subject allow both read and write access to the object. Bidirectional informational flow. The next one is execute. Subject allowed neither read nor write access but may invoke the subject object for execution. There comes the control flow without information transfer. So how do users actually interact with files? BLP defines four models. These are the four models. Read, append, write, execute. Read is only for to view the data. Information flows from file to user. Append only adds data. Information flows from user to file. Write, both read and write. It is a two-way flow. Then comes the execute, which we run a program without reading or writing. But the real systems might tweak these, but the logic stays. Then comes the multi-level security requirements. MLS, multi-level security requirements, means handling data at different security levels. There are actually two golden rules. The first one is no read up. You can't read files above your level, which means you are only per- segregated to a particular level. If you are working in a corporate company, files that, example, databases, only few columns are visible to you. Example, if you are a teacher in VID Chennai, you can only see your details. And if you are a database manager in VIT Chennai, you can only see all the teachers' details, but not the salary details. You are here to only to manage the people's information in the website, not the actual personal informations about where they live, what is their account number, and all that. So this is called no read up. You can't read files at all above your level. There is no write down also. You can't write files below your level. So let us take an example. A high level user cannot write a low level file, but and a low level user can't read a high level file. So this keeps the information safe. The next comes the simple security property, which we also call SS property. This is also known as no reader. Fundamental principle in confidentiality. The definition is meant by a subject can only read an object of less or equal security level. SS property mentions that FC, that is function of SI, is greater than or equal to function of object. SI represents the file and OJ represents the object. Subs where FCSI means the clearance of subject SI and FOOJ means the classification of object OJ. So see this in action. High level user tries to write a low level file, but it is denied. A low level user tries to read a high level file. This is also denied. These are the rule blocks, unauthorized leaks, and access to the users to stop the action. It is just simple, but it is more powerful. Then comes the star property, which is also known as no write down. It is also called as no write down property. Definition goes by greater or equal security level. The formal definition is there is for append and also for write. So the last property, SS property, is called no reader. That rule says only you can read files at or below your security level. Mathematically, there FC of SI is greater than or equal to FO of OJ, which is object. That means your clearance is greater than files classification. For an example of SS property that we have seen before, a security user can't read a top secret file. This is the bedrock of confidentiality. But here, in star property, it is different. The top secret user, while accessing secret level file, the right access is denied. This prevents the information leakage and the protection of the data. The next comes discretionary action control, which is DS property. So let's picture this. A top secret document and a secret cleared user. Can the user read it? No. Access is denied. This property stops unauthorized viewing hold. That's where the actual confidentiality starts. So the discretionary action control DS property defines as an individual or role may grant to another individual or role access to a document based on owner's discretion. Formal definition goes by if SI, OJ, and AX is in B, which in the sense B represents two, a set of objects in which it contains the subject, object, and the owner's discretion. Then the AX is subset of M of SI and OJ, which means the M access matrix of entry of subject SI and object OJ. I hope you understand, and also there are some constraints here. which is the discretionary access is constrained by MAC rules. So here the discretionary access control is shown on the right side of the PPT, which is file owner is requesting a user access, and the file with granted permission, uh, access is granted if the MAC rules are allowed. This enables flexibility with security boundaries. Next comes forward description of PLP model. As we saw already, star model, it is called no write down model that prevents leaks. You can also only write files at or above your at or above your level. For appending, if the function of subject is less than or equal to function of object, that means your level is less than file level, less than or equal. For write, it is actually equal. The function must be equal to the object, means the same level. Only the same level people can write, and only if you are above your level you can read. This is the property of star model, star property, which we have seen. The star was placed as a placeholder that was stuck. Example, a top secret user can't write to a secret file. That's what it means, the star property model. So the description of PLP model states that the system state are represented by four tuples. Four tuple in the sense four rows. Four rows B, M, F and H. So the current access set B, which we already seen, is a set of triples, subject, object and access mode, representing the current access of the user, which he or she can access, whether the file it is accessible or not. Then comes the access matrix M. It records the permitted access modes for subjects, objects. Next is the security level functions. We have already seen FC of SI, which means the function of subject, and FO of OJ. Here it is security clearance, and also FC can also be represented as FS, which in the sense shows us the definition of security clearance of subject SI, and the FO of OJ represents the classification of object OJ. So FC of SI, which is the current security level, FS of SI is the security clearance. So there is the difference between FS and FC, which is FS is security clearance and FC is current security level. So this what provides us this transition model and also gives security to the file. So these are the abstract operations in the PLP model. Imagine a top secret user trying to write secret level file, but it is denied. But it is why? To stop the high level information to leaking into the low levels. This property plugs and it plugs the leaks and keeps the secret so safe so that the higher level people can't write the secret file and the lower level people can't read the secret file. This is what the algorithm states. Then the abstract operations in the BMP model. First one is get access. These are the operations can be included in the code and also can be implemented. First one is get access. Add triple to current access set B. Triple in the sense the set which contains subject, object and access mode, which we have seen before. Next is change object level. Change FO of OJ for object OJ, which is the security clearance of the object, which we have seen before already. And next is give access permission. Add access mode to the matrix M. Matrix M already contains a mode which states that you can either read or write, or either you can't read or you can't write. So this mode access is updated when the user just open the file. It has been processed and the permission access is added to the access matrix M. Then comes the create an object. Attach object to the hierarchy H as a leaf. Next is release access. As get access, it is opposite of get access, release access. Remove the triple from the current access B. What is the triple? Subject, object and access mode. which we have already seen in the previous slide. Next is the current change level. Change FC, which is current state of subject for subject SI, which is FC of SI is being changed. Recent access permission. What is recent access permission? Recent in the sense delete or delete all the information regarding the collected file or regarding the data. Delete all the information regarding that. Recent access permission means delete the complete access mode from the access matrix so that if the higher level user is actually being degraded to a lower level user due to his or her responsibilities, if that happened, the delete access mode, which is recent access permission, helps us to delete the access mode from the access matrix M. Next is the delete a group of objects. Detach an object and subjects from hierarchy H. Hierarchy in the sense which we are seeing right now. The as per the star level, only the top secret users who can access the secret file only can read, but uh, but they can't write. Same way, only the lower level user can only read but no write. No read down, no write up. These are the two main important properties that we have seen before. The star property and the DS property and SS property. This is what the actual abstract operations in the BLP model contains. Next comes the example of BLP use scenario step. Now, discretionary access, we have already seen. File owners can't grant access to others if security rules allow. Formally, let's say that if access is in the matrix and it is permitted, but there is some MAC rules always which overrides the in the code. Example, a file owner can't let a user read only if that user has the right clearance. So this is where the site policy wins. Example of BLBU scenario setup is educational contents, which includes security information and the credential information. As I've already said, database development cell, and or let us take another example of students. As I am, I can't only read few of the information of my classmates, but can't read all the actual information's personal details of the classmates from anywhere. So this is where the security governance comes in place. And next, there is also example for it. Carla and Dirk. Carla is a student role, low security clearance. She doesn't have any permission access to anything, any secret files. So there is someone called Dirk. They have two rules. First one is teacher. Second one is student. Let us take that they are both teacher and student. Okay. So first one is if teacher higher security clearance. If student it is low security clearance. So security level hierarchy will be first the teacher role, then the student role. Why? Because only the teacher have high security clearance. So that is the hierarchy, top to down approach. So this is what the security boundaries means and the access controls means and how the information flows from one object to subject. Sorry, one subject to object. So yeah, there is also another examples of file PLP where we uses file creation and access. This we commonly use in Google Drives and normal Excel sheet that is being like circulated regularly for attendance sheet. Let us say take that example. And also in the sense if a teacher is releasing an Excel sheet and she is giving only a viewer link like let us say a Google Excel sheet, she's only sending the viewer link. Students can only see the link, see the sheet because they have very low access level. But the teacher could edit it. She or he have high security level. So this is what actually means in the file creation and access example. So let us take there is a file F1 created by Dirk, which is who's a teacher, who was in a teacher role. So next file F2 created by Carla, which is created by a student. Carla has C1S low security level. So file 1 which is created by Dirk has C1 plus minus T which is high security level. Access control matrix is based upon no read up, no write down, the star property that we have already discussed before. File creation and access specifically uses star property. Some files use DS property and some files use SS property. These are based on the organizational criteria and requirements. And normally we use star property for the access control matrix, which also have represented here in the file in the PPT right now. No read up or no write down. So the security boundaries, the BLP model enforces these security boundaries between different clearance levels, controlling the information flow. So these are the example of BLP use and some more examples, exam creation and distribution. So there is an exam scenario. First one is roles which required. Dirk must sign as student to create F3 accessible to Carla. Teacher role limitation. In teacher role, Dirk cannot create a file at student level classification. So the exam creation, Dirk creates an exam F4 based on template at C1T level. C1T level in the sense file 1 level. And C1T level is high. So this is what the exam distribution flow happens. First, the teacher role C1T file. Then he creates the exam F4 file. Then Carla gets to see student C1S file, but access is denied. No read-up cannot happen. Why? Carla has low security level. She can't access the exam F4 file. So this is what the exam creation and distribution flow represent. And student submission and teacher access. There is also another example for student submission and teacher access. I have already said a few examples about Google Sheet links. So the same example have been discussed here, but regarding to the file. Carla is a student who needs to submit the answers, but the file FI is at the C1 level. Only the teacher has the exam answers. Carla cannot read the answers, but she can read the questions. So this is what the flow says, that the information flow from student to teacher, only the questions access, read access is allowed, but not the answers. And also write access of the answers are not allowed at any cost. There is another implementation example, important example, which is Multics operating system. Multics overview. Advanced time-sharing OS developed in the 1960s by the MIT. Key features are segmented memory management, advanced file systems, security-focused designs. BLP implementation in Multics. Process level table, security level segments, hierarchical segment structure, enforcement mechanism. When a process attempts access, both discretionary permissions and mandatory rules are checked. This has real-world application and security enforcement. Next is the limitations of BLP model. We are reaching the final stage of the PPT right now. We are in the limitations of the BLP model right now. There is some limitations in this model. That's why which it couldn't work. First one is confidentiality versus integrity. Incompatibility of confidential, uh, which means confidentiality with integrity. Actually, what it means, it focuses on secrecy. That's what it means. The next one is covert channels. Covert channels usually means the shared resources, the star property. It breaks. The shared resources breaks the star property, which tends to say no read up, no write down. Next is untrusted executables. The data high clearance user running at a low level code. That is risky, right? Because high clearance user, if they use low level code, they can access for read or write. Next is the downgrade prevention. Like manual admin work is actually needed for no downgrade prevention at all. So the in the classification 3, the info get overly classified in the sense that if the information get overly classified, the file will automatically become changed. There are some implementation gaps in this PLP model, which is theory versus practice, which is for us, it is important to know the application of the BLP model since we are already using it, the miniature version of the BLP model in our daily life in Excel sheet, Google Forms, documents, and so on. Yeah, all the cloud related architecture use the primary BLP model in it. So here are the summaries and key takeaways, and we are at the end of the presentation. So what we have seen before, the foundational model, the core components, all the properties, SS, DS, and star properties, then the mathematical framework, all the functions and equations, and the real world application using different various examples and all that. So here is the key lesson. These formal models provide discipline and structure for security requirements. Even if it is perfect for implement, even if it is perfect, the implementation is challenging. So it only enforces confidentiality, access control, security levels, and just a formal verification. The implementation of this DLP model is more complex in the today's world. So with this note, I'm ending the presentation. Thank you so much.